question. I oftentimes am curious, why are there two ways to do something? I thought Python told me there should be one and only one obvious way to accomplish any goal, and yet Python is full of multiple choices. We saw this with dictionary merging. There's like 5 choices already. Well, for something even very simple like defining a function, why on earth can I define a function as a lambda or as a defined function? And you might say, well, a lambda is a little bit shorter. It's 1 line. Well, function could be 1 line too. And so you might say, it's not clear why these both exist. And what do we gain out of both of these existing? Well, remember that the difference between a function and a lambda is actually quite minor. There is a difference. The function is much more restrictive. The function can only have one expression that it computes, whereas the def-defined function can have assignments in it and can have multiple lines and return something. And for years, people have been asking for multi-line lambdas, and the core developers said, no. Lambdas are for 1-line things only. It's the case that they are somewhat distinguishable because if you look at the help text of these, you can see the lambda doesn't have a name. And you can see where are we here? Let's scroll up. You can see the lambda doesn't have a name, whereas the function does have a name. And if the lambda happens to have, or if the function happens to have some docstring, the function can have some docstring, but the lambda, there's no place to put that docstring. But that's a very minor difference because you could use functools.wraps to make these look identical. You could say, oh, you know what? F1 is actually exactly the same as F2, so it inherits the same documentation, the same name, and the same argument spec. And so really the difference between a function and a lambda usually comes down to things that you can't do in a lambda. Namely, you can't assign variables, you can have more than one expression that you compute on one that are separated. You can put them in, obviously you can have a list of expressions. You can't define a function, you can't, you can define, but you can't define a function, but you can do lambda. Here I'm going to show you all the things that you can do, you sort of can't do and you sort of can do. You can't import a module, but you sort of can because there's this import function at the top level. You can't define a class, but you sort of can because you can use type. You can't do a context manager. You sort of can because you can call the enter and the exit manually. So you could do like a list where it calls the enter at the beginning and the end. But for the most part, those are contortions, and it's just going to be very difficult. And so the difference between these is, strictly, the function makes certain things really easy to do, and the lambda makes certain things really hard to do, so hard that it's probably not worth doing in the first place. So why does this matter? Why do we even need to know about lambda in the first place? It is a more restrictive function that just jams everything onto one line, and I have never, and I will never tell you that jamming all the code onto one line is anything but a gimmick. It's a bar trick. I do it, but I do it just to impress people when I'm at the bar and somebody tells me they want a Guinness World Record, and I say, you should see how much Python I can write in 1 line of code. Here's why it matters. Fundamentally, every time we see a distinction between 2 different ways to do something in Python, a question can be asked. And that question that we pose is, what are we communicating to people reading our code? And I think the lambda communicates something very interesting. Here is a set of lambdas that I oftentimes write just as part of talking about things like iteration. Nwise longest, first and last. These are generalized ideas of things like to get pairwise. And I'll just kind of show you what they do. Nwise gives you windows, overlapping windows of some specific size. In the intertools module in Python 3.10, they have pairwise, but it's only windows of size 2. Nwise longest does the same thing, but it doesn't end at the shorter of the 2. First helps you identify modalities when you're looping over something, sort of like enumerate, which tells you, oh, we're on element 0, element 1, element 2. Well, first identifies if you're on the first n elements. So I should actually make first n equals 1 as its default, because usually you just want to see am I at the first iteration of this loop. And last does basically the same thing. It says, am I at the last set of elements? And I write these as lambdas. Well, why do I write these as lambdas? 1, because I can jam them through really quickly, and I can type them very quickly, and they don't take a lot of space. And so if I'm live coding for somebody, it's at the top of my screen. That's not a very good reason. 2, because I want to express to you that these things can be encoded with just a single expression. I want to express to you that these very powerful tools can be written by just combining building blocks. That's maybe a better reason. For the most part, I like to do it to express to somebody, oh, this is a function and it doesn't do anything wacky, it doesn't have any statefulness, it's just computing an expression and it's just building up an expression in some particular fashion. And so that's why I like to use lambda. But there is another reason, and maybe one, that is a little bit closer to your use cases. Whenever you look at your code and you're trying to understand, could this code be made better? Could this code be made more understandable? I think it's worth thinking about two things: locality and scope. And when we talk about locality, we often mean both spatial locality and temporal locality, but here we're going to talk about spatial locality. And I'm not going to talk about spatial locality like contiguous memory. We're not here to talk about NumPy, and I think in this session we probably won't talk about NumPy except at the very end. What I mean is locality from the perspective of where the code is located. Here's where lambdas come up very often. Let's say we have some data set, and that data set contains a bunch of entities, some values associated with some names. And we want to minimize over this data set, or we want to maximize over this data set, or we want to sort this data set. But because our underlying data is a named tuple, this will sort them lexicographically. This will minimize lexicographically. What that means is it'll look at the name, and only if the names match will it then look at the next field to tiebreak. So when I do a min or a max or a sorted, I'm actually finding the name that is earliest in the sorting. And in this case, it means the name whose first character has the lowest Unicode code point, which will more or less correspond to alphabetical, except you know that the capital A's come before the lowercase a's in UTF-8 and ASCII and Latin 1 and ISO 8859-1. Usually, when I want to do a min or a max, it is very ad hoc. It's very specific to the thing that I want to do right there on that line of code. And so you could say, oh, you know what thing you could do here is you could add functools.totalOrdering, and you could define an LT, and the LT could specifically say, oh, do self.value versus other.value. And then you can see it actually does minimize the way that I expect it to. But you know what? That I chose to do this by value just happens to be something that I chose on this one specific line of code. It was an ad hoc constraint. And when you think about when you do mins and maxes and sorts, it's oftentimes a part of your analysis layer or your reporting layer. And when you think about your reporting layer and your analysis layer, there's oftentimes a case where somebody says, oh, can you please print this out in alphabetical order? And you do it, and they say, oh, but by this column over here, and you do that, and they say, oh, can you customize which of the two columns? I'll pass a command line flag. Or when you do the analysis, sometimes you want to see the first element, sometimes you want to see the last elements, sometimes you want to see the greatest, sometimes you want to see the smallest, sometimes you see the greatest, and you're like, I wonder what the smallest looks like. There's always this ad hoc nature to it. And so the reason why we might use a key function is the key function allows us to define, the criteria that we want to use on just that one line of code that doesn't need to infect the underlying type itself. It's really just relevant to that line of code. And this key function is a function that takes a single element of data, a datum, I'll refer to this as x, and then extracts from it the field that you care about. And what you can think is, from a locality perspective, if you defined it as a def function, you usually put those at the very top of your script. So there could be many lines of code between where you define this and when you use it. And from a spatial locality, on this line of code, you kind of want all the information necessary to understand what that line of code does. You don't want to be scrolling up and down and up and down. And most of your monitors are wider than they are tall, so that scrolling up and down can sometimes be, kind of pain in the butt. The other thing is, if you had done this, you may want to do something like this. Indicate that other people shouldn't use this function. Because imagine if you were working in a collaborative environment where everybody can see everybody else's code, and you write this function, and somebody else says, oh, this function that does some transformation on the data, maybe this is a more complex transformation that somebody else doesn't really want to have to rewrite themselves or be responsible for getting right. Maybe they're going to do something like normalize NFKD style, the name, as part of the operation, and maybe they're going to do a case fold on this. So, do you really want to have to know all the details of different Unicode normalization form and whatnot? Probably not. So somebody external to you and your project finds your library, uses this one function from your library or from your script, imports it, and is off to the races. And you know what happens? Later on you say, you know what, I changed my desire for which normalization form I want to use. I want to use this normalization form. And suddenly you get a call up out of nowhere. my code broke. Why'd you change that thing? And you say, what thing? And you say, oh, the function that extracts from the data, the Unicode normalized name for the purpose, and case folds it for the purpose of the comparison. And you say, I didn't expect anybody else was supposed to use that. You're not supposed to touch that. That's just for me. And that's maybe why you might put underscores here to just say, you know what, don't touch this. But another way you could express the same idea is using a lambda. One of the things that I like about lambda is it not only keeps things local, but it really, really nicely expresses the idea of this is ad hoc, this is not to be shared. Don't try and get a handle on this thing. Don't try and get a reference to this thing and use it in your own code. It really only exists on this line of code. And these lambdas come up all the time, anytime you're doing some operation that is idiosyncratic, that's just specific to the code that's right there in front of your face, and you want to see it all in one place. That's why lambda exists, and that's why lambda matters.